The hook, the disruption of the silent void. The pitch-black silence of the Hadal Zone is not truly silent, but rather a delicate symphony of biological clicks and low-frequency pulses. Suddenly, a violent, metallic shriek tears through the water column. It is a sound so intense that it vibrates through the very flesh of every living organism for miles. A colossal squid, drifting in the darkness, begins to spin uncontrollably. Its sophisticated sensory organs, designed to detect the faint movement of prey, are now being overwhelmed by a physical force it cannot comprehend. Nearby, a group of Cuvier's beaked whales, the master divers of the mammal world, abandon their hunt in a state of sheer panic. They do not swim upward gradually. They bolt toward the surface in a desperate attempt to escape the invisible wall of noise, unaware that the rapid change in pressure is bubbling the nitrogen in their blood. The introduction of the unseen intrusion. The deep ocean remains one of the last frontiers of Earth, a realm where light dies and pressure crushes. For millions of years, the inhabitants of this void have relied almost exclusively on sound and vibration to navigate, hunt, and communicate. However, the modern era has introduced a new dominant force: human-generated sonar. Used for naval exercises, oil exploration, and seafloor mapping, these acoustic pulses travel further and faster in water than in air. While humans see the ocean as a visual expanse, the creatures within it experience it as an acoustic landscape. When a ship sends a sonar signal downward, it is not just a tool for measurement, it is a profound intrusion into a fragile ecosystem. This article examines the biological and behavioral shifts of deep-sea fauna as they encounter the technological ping of the human world. The middle, a symphony of chaos. The reaction of deep-sea animals to sonar is not uniform, but it is universally disruptive. For many species, sound is their primary sense. Cetaceans, such as the sperm whale, use biological sonar to locate prey in total darkness. When artificial sonar frequencies overlap with these biological signals, the result is acoustic masking. The whales can no longer see their environment. Observations have shown that sperm whales will cease their feeding calls for hours, even days, after a single sonar event. This leads to significant energetic costs, as these giants require massive amounts of food to survive the cold depths. Further down, in the bathypelagic zone, the impact becomes more physical. Studies on cephalopods, including various species of deep-sea squid and octopuses, have revealed that low-frequency sounds can cause trauma to their statocysts. These are the fluid-filled organs responsible for balance and orientation. When exposed to high-intensity sonar, these organs can actually rupture. A disoriented squid is a dead squid. Unable to maintain its position in the water column, it may drift into warmer waters or become easy prey for surface predators. The behavioral changes are equally chilling. In the presence of active sonar, deep diving whales have been observed performing abnormal diving patterns. Instead of their usual calculated ascents, they perform jagged, frantic maneuvers. This behavior is linked to mass stranding seen on coastlines globally. The sonar acts as a psychological trigger, evoking a flight response that overrides the animal's natural survival instincts regarding pressure management. The abyss, once a sanctuary of darkness, becomes a hall of mirrors where every reflection is a deafening, painful lie. The climax, the breaking point of the deep. The tension reaches its peak when multiple sonar sources are used simultaneously during large-scale naval maneuvers. In these moments, the ocean becomes a dead zone of sound. Marine biologists monitoring hydrophones have recorded the haunting silence that follows a heavy sonar blast, a silence not of peace, but of absence. The biological chorus of the deep sea simply stops. The apex predators flee, the midwater fish scatter, and the delicate balance of the food web is thrown into disarray. In the deepest trenches, the impact on truly deep-sea dwellers, creatures that never see the sun, is still being calculated. These animals are evolved for extreme stability. Their environment changes very little over millennia. The sudden introduction of high decibel energy is a shock to their nervous systems that can lead to systemic cellular stress. Scientific expeditions have recovered specimens with internal hemorrhaging around the brain and auditory tissues, directly linked to the timing of nearby sonar testing. This is the hidden cost of human curiosity and defense, the potential permanent deafness or death of species that humans have yet to even name. Conclusion: the echo of responsibility. The story of sonar in the deep sea is one of a clash between two worlds. One world is driven by the need for data, security, and resources. The other is driven by ancient rhythmic survival. As the signals fade into the silt of the ocean floor, the long-term consequences remain. The deep-sea animals that survive the initial blast are often left with permanent hearing loss, making them unable to find mates or avoid predators. The abyss is not a void. It is a crowded, living space that breathes through sound. If the human world continues to broadcast its presence without regard for the acoustic sensitivity of the deep, it risks turning the ocean's greatest sanctuary into a graveyard of silence. Understanding the response of these creatures is the first step towards creating quiet technologies that allow humans to explore the depths without destroying the very life they seek to discover. The echoes we send into the deep eventually return to us, carrying the weight of a world we are only beginning to understand.